Today, we studied section 3, section 4, and section 5. All the 3 sections are about derivative formulas. It is important to know that all the formulas were derived from the definition, namely from these 2 formulas. For example, derivative of sine is cosine. How to get this result? To compute the derivative of sine, we have 2 formulas to use. Let me use the second formula. By the second formula, derivative of sine is this limit. Now, expand sine of x plus h by this trigonometry formula, then I have this equation. In the numerator, I combine the first term and the third term, and taking out sine of x, then I get this term. The middle term over h is this term. In this limit, x is fixed, h is changing, h is approaching 0. By tables, it is easy to see that as h approaches 0, cosine of h minus 1 over h approaches 0. And sine of h over h approaches 1. Therefore, as h approaches 0, this sum approaches sine of x times 0 plus cosine of x times 1. This is cosine of x. Therefore, derivative of sine is cosine. The book has done the tedious part for us. The tedious part is this part. The book has done this part for us and only show us the final result. Derivative of sine is cosine. This is the formula for the derivative of sine. There are 10 formulas. I divide the 10 formulas into 2 groups, and I name the first group as general formulas. The formulas in this group work for general functions. I name the second group as formulas for special functions. The formulas in this group are only for special functions. Now, let me present the formulas in group number 1. The first formula: a constant times a function, then take derivative is the constant times the derivative of the function. Namely, we can move the constant outside the derivative. For example, 3 times the function x squared, then derivative, we can move the number 3 outside the derivative. The second formula, summation rule. Derivative of a sum is sum of the 2 derivatives. For example, tangent plus x squared, then derivative is equal to derivative of tangent plus derivative of x squared. The third formula, difference rule. Derivative of a difference is difference of the two derivatives. For example, lateral log minus sine, then derivative is derivative of lateral log minus the derivative of sine. The fourth formula, product rule. Product rule says that derivative of a product is the derivative of the first function times the second function plus the first function times the derivative of the second function. For example, x squared times e to x, then derivative is derivative of x squared times ex plus x squared times the derivative of ex. Please note that derivative of a product is not equal to product of the derivatives. The fifth formula, quotient rule. Derivative of a quotient is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, or divided by the square of the denominator. For example, 1 over x, this is a quotient. By quotient rule, derivative of 1 over x is derivative of 1 times x minus 1 times derivative of x, then divided by x squared. Please note that derivative of a quotient is not equal to quotient of the derivatives. Now, formulas in group number 2. The formulas in this group are for special functions. Formula number 6. Derivative of a constant is 0. Plot the graph of the constant. The graph is a horizontal line. Derivative is the slope of a tangent line. On the horizontal line, everywhere the tangent line is horizontal. Therefore, derivative everywhere is 0. Formula number 7. Derivative of the power function x to a is a times x to a minus 1. For example, derivative of the cubic root of x. Cubic root of x is a power function, x to 1/3. By this formula, derivative of x to 1/3 is 1/3 times x to 1/3 minus 1. Derivative of x, we can view x as a power function, x to 1. Then by this formula, this derivative is 1 times x to 1 minus 1 is x to 0. X to 0 is 1. Therefore, derivative of x is 1. The graph of x is this line. This line, everywhere the slope is 1. Therefore, derivative of x is equal to 1. Formula number 8. Derivative of the exponential function a to x is a to x times natural log of a. In particular, derivative of ex is ex times natural log of e. Natural log of e is 1, so derivative of ex is ex. There are two functions, only two functions. After you take derivative on them, the derivatives are the function themselves. These two functions are ex and 0. Only these two functions. Their derivative are the function themselves. For example, derivative of 3x is 3x times natural log of 3. Formula number 9, trigonometric functions. Derivative of sine is cosine. Cosine derivative is negative sine. Pay attention here. It is negative sine. Don't miss negative. Derivative of tangent is secant square. Secant square means secant of x times secant of x. There are 6 trigonometric formulas. I suggest that you only remember the formulas for sine and cosine, together with the formula for tangent. The formulas for sine and cosine are enough for us to use because all trigonometry functions can be expressed in terms of sine and cosine. Formula number 10, logarithmic functions. Derivative of log of x is 1 over x times natural log of a. In this formula, x is positive. Derivative of log of absolute value of x is 1 over x times natural log of a. In this formula, the x can be positive, can be negative, but cannot be 0. In particular, derivative of natural log. Natural log is a log with base. Base is e. Derivative on this log by formula is 1 over x times natural log of e. Natural log of e is equal to 1, so 1 over x. Derivative of natural log is 1 over x. Similarly, derivative of absolute value of x is 1 over x. Now, some examples about how to use the 10 formulas. Example 1, differentiate tangent of x. Differentiate a function means compute the derivative of the function. Derivative of tangent is secant square. How to get this result? Express tangent in terms of sine and cosine. Then derivative of tangent is the derivative of this quotient. The top function is sine, the bottom function is cosine. By quotient formula is here. By quotient formula, this derivative is derivative on the top times the bottom minus the top times derivative of the bottom, then all divided by the square of the bottom. Derivative of sine is cosine. Derivative of cosine is negative sine. So cosine times cosine minus sine times negative sine is cosine square plus sine square. But cosine square plus sine square is equal to 1. This is a well-known formula from trigonometry class. So derivative of tangent is 1 over cosine square. 1 over cosine is secant. So 1 over cosine square is secant square. So we get this formula for tangent. Example 2, find the derivative of this polynomial. There are 2 solutions. In solution 1, I want to use the definition to compute this derivative. The definition says that the derivative is a limit. In order to use the definition to compute the derivative, let me give a name to this polynomial. I name the polynomial by f. Then derivative of function f is this limit by definition. To find f of x plus h, in this equation, replace all the x by x plus h. Then f of x plus h is this. F of x is this polynomial. Then I have this equation. To find this limit, plug in 0 in h, but then I will have 0 over 0. I cannot tell the limit. To tell the limit, simplify the function. I expand the 2 powers. These 2 powers, expand them. Then I see many cancellations. This solution is very tedious. Let me skip this solution. In solution 2, I use the 10 formulas to compute this derivative. By summation and subtraction formula, I have this equation. By a constant times a function formula, I can move the number 12 outside this derivative and the number 6 outside this derivative to get this equation. Derivative of the power function x to 8 and derivative of the power function x to the 5th. I can apply the formula for power function. Then I have this equation. Now simplify this expression. 12 times 5 is 60. This is 6. Then derivative of this polynomial is this polynomial. Example 3. The function f be this polynomial. Part A, find the values of x for which the slope of the curve is 0. The slope of the curve means the slope of the tangent line to the curve. B, part B. Find the values of x for which the slope of the curve is 21. Suppose this curve is the graph of this function. At some point on the graph, the tangent line is horizontal. You need to determine the x-coordinate of the point. Because this point is on the graph of the function, y-coordinate of this point is the function value at the x-coordinate. Similarly, at some other point, the tangent line has slope 21. You need to determine the x-coordinate of this point. To answer the questions, we compute derivative of the function because derivative is slope of tangent line. Now take derivative on the function. By summation and subtraction formula, we have this equation. Move 27 outside this derivative, then we have this equation. Now, derivative of the power function x to the third is 3 times x squared by this formula. Derivative of x is 1. Derivative of the constant 5 is 0. Therefore, this is the derivative of this function. This is the slope of the tangent line to the graph of this function at the point x. Now, to find the x-coordinate of this point, set the derivative of the function to 0 and solve this equation. Move 27 to the right side, divide this equation by 3, then we have this equation. Take square root on the both sides. When you take square root, don't forget adding plus, minus here. So there are two x values, -3 and +3. Their derivative is 0. Derivative is slope of tangent line. So at these two x values, slope of the graph of the function is 0. Similarly, to answer part B, to find the x-coordinate of this point, set the derivative of the function to 21. The slope of this tangent line is 21. And solve this equation. Move 27 to the right side, divide this equation by the number 3. Then we have this equation. Take square root on the both sides. Don't forget adding plus minus. So x is equal to -4 or +4. Conclusion. The slope of the curve is 21 at these two x values. Example 4, differentiate these functions. Differentiate a function means compute the derivative of the function. Part A, The function in part A is a product. It is this guy times itself. So to compute the derivative of this function, we can use the product formula. But I prefer to simplify the function first before I compute the derivative. Write these two terms in power. Square root of x is x to 1/2. 1 over the cubic root of x is x to -1/3. Now, expand the square here by this formula. Then we have this equation. X to 1/2, then square. I can simplify this by this formula. By this formula, this is x to 1/2 times 2. It is x to 1. X to 1 is x. Now this term, x to 1/2 times x to -1/3. I can use this formula to simplify it. By this formula, this product is x to 1/2 minus 1/3 plus this term, x to -1/3, then square. By this formula, this is x to -1/3 times 2. It is x to -2/3. 1/2 minus 1/3 is 1/6. So the original function now is simplified to this function. In this function, each term is a power. After the function is simplified, now compute the derivative of the function. Take derivative on this function. By summation formula, this derivative is the sum of these three derivatives. Move the constant tool outside this derivative, then we have this equation. Now, derivative of x is 1. Derivative of the power function x to 1/6 is 1/6 times x to 1/6 minus 1 by this formula. Derivative of the power function x to -2/3 is -2/3 times x to -2/3 minus 1 by this formula. Now simplify this expression. 1/6 minus 1 is -5/6. -2/3 minus 1 is -5/3. 2 times 1/6 is 1/3. Then derivative of the function is this function. Part B. The function in part B is a quotient. So we can use the quotient formula to compute the derivative of this function. But I prefer to simplify the function before I compute the derivative. To simplify this function, split this quotient into a sum of smaller quotients. X squared over square root of x, square root of x is x to 1/2. By this formula, x squared over x to 1/2 is x to 2 minus 1/2. X over x to 1/2 is x to 1 minus 1/2 by this formula. Now 1 over square root of x is x to negative 1/2. Now simplify the powers. 2 minus 1/2 is 3/2. 1 minus 1/2 is 1/2. Then all the terms now are powers. Now I compute derivative. Take derivative on this function. By summation formula, this derivative is a sum of these three derivatives. Move the constant 4 outside this derivative and the constant 3 outside this derivative. Then we have this equation. Now, the derivative of the power function x to 3/2 is 3/2 times x 3/2 minus 1 by this formula. Derivative of x to 1/2 is 1/2 times x to 1/2 minus 1 by this formula. Derivative of the power function x to negative 1/2 is negative 1/2 times x to negative 1/2 minus 1 by the same formula. Now simplify this expression. 3/2 minus 1, 1/2. 4 times 1/2 is 2. 1/2 minus 1, negative 1/2. 3 times negative 1/2 is negative 3/2. And negative 1/2 minus 1, negative 3/2. This is the derivative of this function. Part C. The function in part C is a product. You can simplify the function by expanding the product before computing the derivative. But this time, let me use product formula to compute the derivative of this function. By the product formula, the derivative is equal to derivative of the first function, x minus 2, times the second function, 2x plus 3, plus the first function times the derivative of the second function. X minus 2 derivative by the difference formula is x derivative minus 2 derivative. 2x plus 3 derivative is 2x derivative plus 3 derivative by the summation formula. Now move the number 2 here outside the derivative, then we have this equation. X derivative is 1, 2 constant derivative is 0. X derivative is 1, 3 derivative is 0. Then we have this equation. Simplify this expression, then we have 4x minus 1. This is the derivative of this function. Part D. In this function, A, B, and C are constants. They are some numbers. Before I compute the derivative, I write the second term and the third term in powers. B over x is B times x to negative 1. C over x squared is C times x to negative 2. Now, take derivative on this function. By summation formula, the derivative is the sum of these three derivatives. Because A, B, and C are constants, I can move them outside the derivatives to get this equation. Now, Ex derivative is Ex. X to negative 1 derivative is negative 1 times x to negative 1 minus 1 by this formula. X to negative 2 derivative is negative 2 times x to negative 2 minus 1 by the same formula. Simplify this expression, then this is the answer to Part D.